Let's look at another problem that comes up quite often, and that is the ability to query cache results from a DBMS such as MySQL and store the results in MemCacheD. So we've got a simple include script here. You can retrofit this to determine whether or not files are to be included. And again, just to quickly elaborate a little bit more, it could be stretched a little bit beyond just the body of the page. So for example, our website includes a nav header, as do many websites. So this could be stuffed into MemCacheD because these contents seldom change, and as a consequence would result from a faster load time. Then this would be the body area. Perhaps this would be a SQL query, MySQL query area. And then below, we'd have a footer area. These are all areas that could be stuffed into MemCacheD in order to scale your site if necessary. Now let's take a look at our gedit and see what else might be of use to us. So back to our notes for a moment, and it's still PHP integration, but more so PHP, MySQL, MemCacheD integration. So the idea here is that we're able to cache query results. Certainly MySQL can provide this facility for us, but not as fast as MemCacheD, and as a consequence, it's rather advantageous to store results in the Memcache cache. And not to mention, we get to benefit from clustering, moving key value pairs all over the place, and not having to worry about table changes and validating the MySQL cache. So you can cache with your DBMSs, but Memcache provides advantages, which is why it's used. So caches query results, and the query results that are returned to us are structures that must be serialized. And by serialized, we really mean flattening it out to strings. So flattened to strings for ultimate storage in the Memcache cache, or MemCacheD, perhaps in your cluster. So this is important. So we get the results, we have to serialize them, and then when we're ready to use the results, we unserialize them. So unserialize stored results when needed. And of course, PHP provides the functions. So note, PHP, as do other languages, provide appropriate functions to serialize and deserialize accordingly. So there's some steps to make this work. Let's just give a rough outline. So first we connect in our script to MemCacheD. Always check your cache first. We check Memcache as usual, just as we've shown from the command line, for the key or keys of interest. And if present, use. If not, query DB and populate MemCacheD. Of course, after we query the DB, use in page, web page, and then populate the MemCacheD. And then that means, of course, subsequent hits will come from the cache. So let's construct a string based on a predefined database. Let's give you a quick look at what's already defined on our remote system. So let's do a which MySQL, see if we've got the client installed. We don't. So if we run the script here, it'll operate across the wire. So if we want everything to run on the remote side, localhost, then we'd need to construct the script on that remote system. So let's SSH to a system that has MySQL already installed and place a script there. So that'll be Linux CBT build 2 as the user Linux CBT. We could also do it across the wire, either or. And then on this remote side, let's make a directory, memcache, and let's connect to the database just to confirm what's there. So let's use products, show tables. We have a simple structure in place, and let's select star from users products. So we've created some records. LinuxCBT, myself, MemCacheD. 2 columns, well actually 3 with an auto-generating ID, so 3 columns. So this is a hash that can be stored in Memcache, but again it needs to be serialized and then unserialized to be stored properly. So we're accustomed to working with single values. For example, you hit a website, let's say Facebook, you see single value entries come back such as your email address, maybe one or more areas, but they could be stored across a hash like this and stored in Memcache and referenced accordingly. So how do we take this table, stick it into MemCacheD, and ensure that we hit the cache to retrieve those results when necessary? So let's quit MySQL, and we've just connected with this connect string, user LinuxCBT password ABC123. So we need to stick all of this into a script and test it accordingly. Now this system also has Memcache. If we netstat ntlp grep mem, we should see that an instance is running. Let's drop p because we don't have privileges. And let's see if it finds it. It doesn't find it. Let's do a case insensitive mem pscf grep. That's netstat. The p isn't coming back, so let's look for mem. There's Memcache running with 64 megs. So there is an instance there that we can populate, so no problems whatsoever. And so far as a script, let's use nano, and we'll call this test memcache php mysql.php. We'll specify the path, although it's not necessary, but if we're going to run it from the shell as opposed to the browser, that's fine. So user bin php, that's location if we do flag this executable. So we need to define a connection string to connect to the DB. So DB connection, and that'll include, of course, username, password, the name of the database, as well as the host. So DB user. Let's set this to the user we just used, LinuxCBT. DB pass, ABC123. And these are variables, so they must be prefixed. DB name, this is products, simple database. DB host, defaults to localhost, but we'll explicitly specify it just to avoid any headaches. So that gives us the creds. Now we need to set up a connection string. Typical connection string uses MySQL for example, or you include it from some sort of DB connect script. That's what we typically do. So include it from somewhere that's outside of the web root. So connect step, and that's going to be MySQL This is the object. We'll create a new MySQL instance. And in between parentheses, we'll specify the host, the username, the password, and the database name to which to connect in that order. So DB host, DB user, followed by DB pass, and single or double, but since it has to be interpolated, let's just include double to avoid any issues with interpolation, and DB name. This will connect us to the products database. Now, if this is good, then we move forward. So let's just double check. If MySQL connect error no, typical function we call, then we print something along the lines of connection to DB failed. And we send the variable in, %s, new line, and the actual error. So MySQL connect error, and then terminate. This is in the event that there's a problem. And of course, we should exit the script if we can't get to the database. But it depends, because your results may be in the cache, but usually we want to be sure that the DB is accessible and bail otherwise. Now, let's try to get the information from the cache. So fetch or attempt cache fetch. Of course, this is MemCacheD. Let's see what happens. So typical MC is equal to new memcache, and then we'll try to connect, let's say, to the local host for these records. And then if it works, we can always spread the values across our cluster. So we'll connect to the local host to its 12111 port. And if that goes well, then we try to get the results and store it into a variable. So because the results will be represented as an array that needs to be deserialize or unserialize. Let's define an array. So define container array for MemCacheD key value pair. Because what will be stored from a database table will be really a hash, so it'll be multiple arrays. So let's go ahead and call this MCD. So MCD is basically going to be the data coming off of Memcache. So MCD is equal to a new array, construct a new array. Nothing's in it just yet. And then the critical step, let's try to get the information from MemCacheD using a get. Now let's say the key is simply called MCD for Memcache data. Just one key which will point to the various values in the MySQL products database in the user's products table. So if this goes well, then we'll have the results from MemCacheD. Otherwise, we have to query the database and populate accordingly. So perhaps the first thing we check for is whether or not it's false. So if MCD, and you can also check if it's null. There are other ways to do it, but this is just one way. So if this particular variable MCD is false, meaning the key didn't come back, which is equivalent to using MemCat in search of a particular key, or memcdump grepping the key that's of interest. So if it comes back false, then we should construct our SQL. We'll just call this SQL1, for example. And that'll just be a simple select star. It could be as complex as you need it to be with all the joins, etc. Let's select star from users, products. And that's our query. Now you'll often see online people using MD5 to hash the query or the key name that's tied to the query. That's optional as well. It's just a way of uniquely identifying that particular key. So the presumption is that each query is a unique key that's tied into MemCacheD. So that's just another way of doing it. But just for simplicity, let's do it this way. So we have our SQL statement. So the next step now for us is to try and fetch the data. So if, and we usually use a variable called result, if result is equal to the MySQL I connection object, we launch a query and we try to fetch the results of this query SQL1. So if the result is positive, then we loop over it and set it to an array that will then push into Memcache. The way we loop over these results coming off of SQL or MySQL or any SQL, for example, is just to use a while loop. This is one way to do it. You set a variable that'll hold each record through each iteration of the loop. So let's call this rec for record, and we'll set it equal to result, and we'll fetch the association. And then if that goes well, within the loop, we'll set a variable MCD to be an array container, which is equivalent to the current record. And then that'll populate it for us. And if it's populated, then we try to set the memcache with this new value. So we do an MC set. And in between parentheses, we specify the name of the key. Let's call MCD. This is a key that you'll often see hashed online. And the important thing here is to serialize it. So serialize the key, or the values tied to the key, that is. Serialize MCD, no flags, and let it be good for 30 seconds. That should take care of that. And then here we close out the if block. And then we get into our else block. So the else block should do something along the lines of simply unserializing the results if it's in the cache and printing it. Now, one thing we can start with is a var dump, just to see what's there when it is there. So the first time will be a miss, the second time will be a hit when we run this script. So we'll var dump unserialize MCD if it's in the cache. If it's not in the cache, again, it'll be populated. And then we finish the script. Again, we're running through it rather quickly, but it's rather straightforward. We'll show you what this means. So let's just quickly sum this up. So we connect to the database. If it's good, then at least we have the database connection object ready to go. Now, the connection actually isn't made till later on. We just define the connection that needs to be made. Along the way, we decide to try Memcache first because it's a faster, more expedient route. So we connect. We set an array because if it's going to be associative information coming off of a database, like a table structure, two-dimensional table structure, or deeper, then it needs to be stored in an array structure. Generally, you return two-dimensional arrays when you query, no matter how many joins you use. So if we get the results, this whole block is ignored. But if the results are false, we construct a query, a MySQL query, since we're using MySQL, and then we execute that query, and each iteration through the query, so let's just go ahead here, execute query. Each iteration through the query will set the current record to MCD. So set current record to var MCD. That's what happens at that stage. And then it'll populate it, create a table structure, and then we populate memcache. So let's just note populate memcached, or at least attempt to. Let's just note that as well, because some error handling should be wrapped around this. So attempt to populate. And let's just also note wrap error handling accordingly. For expediency, we tend to ignore it just to get through the point, but you can always build that in. So it needs to be serialized. If we're going to store it, it has to be serialized, because we're taking basically a structured set of information from MySQL and then turning it into a flat list of data, a string that is. So convert MySQL structure, and it could be any DB, to string. This is the serialization step. Then it stores it. Now, on the second run, this whole block will be avoided, and var dump will unserialize MCD, which is stored in memcache. So let's just note, if we are here, MCD is in MemCacheD. So deserialize and display records. And if that's good, then we'll take the step to loop through the results and print them accordingly as we see fit. Again, you're going to get an associative array, but this should be good. Not too many lines. Let's see where we are. 42 lines, no problem. So let's go ahead and save the changes to this, and maybe we'll open another window just to have two going. So let's SSH to Linux CBT build 2, and the user isn't defined, or they're not lining up, that is. And then we'll navigate into memcache, and then we'll PHP test and see what happens. Now, it doesn't have the wrapping PHP tags, so that is definitely something we want to include. And let's try that again. It gives us a little debug. Otherwise, it dumps it. So let's see what happens here. Unexpected on line 12. And that's left curly brace. Let's see what's happening here. And that's going to be 13. So if, let's double check all of this, we should have MySQL connect. This doesn't look right. MySQL I underscore connect underscore, not parentheses, error number. That's more like it. So let's try it again. Memcache server localhost failed with connection, refuse, so on and so forth. Let's see what's happening. So it failed. So this is something we'd certainly want to handle. That's that NTL. See what's happening with, and it's on 11211. So this is trying to use the loopback adapter. So this is another thing you see often online. Actually, this is for MySQL. When you connect to localhost, that it bombs. So let's put the IP address in. It is actually suggested that you use the IP, the routable IP that is, as opposed to localhost. And if thinking in terms of clusters, then certainly loopback won't help. Let's try it again, see if it's able to connect this time. And let's see what's happening here. Server 12111, UDP 0. And the problem actually isn't loopback, it's the port that's Try that again. 11211. Let's just double check it, and that's what it is. That's more like it. Okay, so let's see what's happening. So we had nothing print the first time around. As far as the script is concerned, it ran. Now let's try it again, and there's your var dump. Now let's scroll up. So now it's in the cache. And because PHP and the memc utilities are both using live memcache, then we're able to interact, or the same hashing algorithm via live memcache, we're able to interact with the results from both perspectives. Now these results are only good for 30 seconds because that's the timer that we set. So the first record represents the auto ID 1 as well as column user, column product. Ditto for second result, third. So this is an associative array. So the first element of this array contains an array. Second element contains an array. Third element contains an array. So the results are currently there. Let's see currently with MemCacheD servers, localhost, MCD. Now it's empty. Now let's rerun the script. First time fails. MemCacheD. This is serialized data representing the results from MySQL. So to retrieve these data, we now need to unserialize or deserialize the results as we dump them. So the var dump simply shows you the structure of that serialized data. Now let's take a look in our script. Var dump, notice, has the unserialized. So this is working. And since we're at this step, let's go ahead and set a variable, loop over the results, and extract what's necessary from memcache. So script is working. Data are serialized. And then deserialized. But we haven't set it to a variable. We just did a var dump. So now let's set a new variable. Say mcd2 is equal to unserialize mcd, which is this variable here. We could remove that one, but that's fine. So this will create an unserialized instance. Now once we have this unserialized instance, we can loop over the results using for each. So loop over array with for each. And let's just include a hash mark for consistency. So for each, just like with Perl, mcd2, which is an array. Now, just to give you a sense for where we are, if we take a look here, for each first element gives us these distinct elements which are nested within the nested array. Second element gives us these items, and so on. So and we can call these by their keys, for example. So we can say give us the second element, which is indexed at 1, and user, for example. So for each mcd2 as some temporary value. So it could even be I, the common I, if you'd like. And as we're looping, we can then start to echo distinct items. So let's say we want the user. So the user would be returned as I user. And then at the end of it, we send a new line character so we don't corrupt the shell. And then we terminate the for each. So let's pull this out and see how it looks. And that should be on this. Actually, we can do it from here. Let's try it out. MCD is not there, so we're going to have to populate it, so the first time won't show anything. Now, by the way, in the first block, where we actually populate the DB, that's this block, we should, while we're iterating through these results, print the results that are necessary. So some sort of print statement like there. Now let's see, MCD is there. Now let's rerun. And there we see our results. So user, first user, second user, third. And of course we can sort the results. And if you want other columns, then just specify those columns accordingly. So we've got user. Maybe we want product. And that'll be I and the key product with a space and so on. And you can organize these columns however you see fit, and just check for errors as you launch, and you should see. So user, product, so on and so forth. So the way this works, again, the idea is that for sections of your website, for your web application that you think could benefit from MemCacheD, because not all web applications will, what you want to do is first check the cache. That's always the case. And again, instead of connect, you'd use the add servers to load in all your servers. Check the cache. If the cache has the data, then the first block is avoided altogether, and then the items are deserialized and dumped accordingly. But if the cache is empty, which we expect because of the 30-second timer, it'll fall into the false section, at which point you run your DB code. Now, this could just be an include. You could have an include here from another file to do the code for you. And of course, certainly keep your credentials out of this file. Do an include from another file. And again, if we're in this block, then that means the data exists in